So chapter 3 is called Analytic Trigonometry, and this is the heart of what you're going to be needing for calculus, is to be able to use trigonometry. So section 3.1, we're talking about the inverse sine, inverse cosine, and inverse tangent functions, and that's why we reviewed inverse functions last week. So we're going to start by filling in these objectives, and the first one is to find the exact value of an inverse sine function. So exact value. Then the second objective is going to be to find an approximate value of an inverse sine function, because that will be using our calculator. The third is to use the properties of inverse functions to find exact values of certain composite functions. So remember, that's what you get when you compose two functions, is a composite function. Then we're going to skip the find the inverse function of a trig function. That's the derivation of this idea. We just need to know how to use it. So the last thing we're going to do is to solve equations involving inverse trig functions. So recall that the function y equals x squared, or we can write it f of x equals x squared. Remember that that's your basic upward opening parabola, and that if we look at the whole thing, it's not one-to-one. But if we restrict the domain to only values of x that are greater than or equal to 0, then the function f of x equals x squared, and we put a comma, x greater than or equal to 0, to say the domain is restricted. It is one-to-one. So here's our picture. So let's talk about the inverse sine function given this idea of restricting the domain. So let's consider the function y equals sine x, which we can also write as f of x equals sine x. Remember, f of x and y always interchangeable. By looking at the graph and applying the horizontal line test, so here's our sine graph, and it continues in both directions indefinitely, right? We can see that it's not even close to being one-to-one. If we apply the horizontal line test, it's going to hit the graph in infinitely many places, no matter where we put it. But if we restrict the domain to negative pi over 2 to pi over 2, including the endpoints, so here is negative pi over 2 to pi over 2, now you can see that this piece of the sine graph is one-to-one. If we picked a piece that was a hump like this, that would fail the horizontal line test. Or if we picked the piece down here, that would fail the horizontal line test. So yes, there are infinitely many pieces of the graph that would work to restrict the domain to, for instance, pi over 2 to 3 pi over 2. But we all agree, this is called a convention. We all agree that we will restrict the domain to negative pi over 2 to pi over 2, endpoints included. And then we have the guarantee from section 1.8 that this function with its restricted domain has an inverse function. So the convention is that we restrict the domain to negative pi over 2 to pi over 2, and your calculator follows this domain restriction, this convention. So it will only give you answers that fall in this interval. So there's lots of other choices that would work, but we all agree to limit the domain in this way so there's no confusion. So now we know the function y equals sine x has an inverse function. So how do we find it? Well, we already have a procedure. We say, let's take y equals sine x, and then interchange x and y. So then we say x equals sine y, and we solve the resulting equation for y. Well, the way we do that is to apply the sine inverse function to the left and the sine inverse function to the right. But we say if we do f inverse of f of y, we get y. So clearly sine inverse of x must equal y. And then we write the inverse function is sine inverse of x. So that's what it looks like. And remember that this is the inverse function. When the exponent is here, that's the inverse function. If we want to say 1 over sine x, we need to use a grouping symbol and say sine x to the -1 power. So make sure you're very clear on what this superscript -1 means depending on how it's used. Here, when it's used, it means inverse. Here, it means reciprocal, or it's being a negative exponent. So make sure you're very clear on that. So notice that sine inverse of x is not the reciprocal. So we read y equals sine inverse x as y is the angle or real number in quadrant 1 or 4 with a sine of x. So make sure that makes sense to you, because y is the sine of a number. So note that the inverse sine of x represents an angle. Make sure that makes sense to you. You may also see the notation arc sine with a capital A, or just a sine. This is the notation on my calculator. So your calculator may have either sine inverse x, or it may say a sin x, and those mean the same thing. So remember this important distinction that if I put the -1 exponent superscript here, it means the inverse function and not the reciprocal. So the one on the left is an angle. The one on the right is equal to the cosecant. So find the inverse sine button on your calculator, whatever it looks like. And then let's look at the graph, remembering from section 1.8 that the graph of an inverse function is the graph of the original function reflected about the line y equals x. So we draw a graph of y equals sine x, so that's the pink one here. Then we reflect it point by point about the line y equals x, and you're going to come upon this blue graph, and that's what the graph of y equals sine inverse of x looks like. So for the function y equals sine x, we can see that the domain is restricted to -π/2 to π/2, and the range is going from -1 to 1. So because of what we studied in section 1.8, we know that for the function f of x equals sine inverse of x, that it must be true that the domain is -1 to 1. So the things you put in here have to be an element of or belong to the set of -1 to 1. You can't put a 2 in there. It doesn't make any sense. Then the range, the outputs, will be between -π/2 and π/2. And if you're thinking unit circle, then this is quadrant 4 or quadrant 1. And your answer will always come out in quadrant 4 or quadrant 1. So this blue box shows you the definition. It says y equals sine inverse of x means x equals the sine of y. So see how here y is an angle in this interval, and x is a number in this interval. Okay, so objective 1 is finding the exact value of an inverse sine function, and we can use our chart for this. So hopefully you're getting really fast at drawing this chart. 0, pi over 6, pi over 4, pi over 3, pi over 2, 0, 1/2, root 2 over 2, root 3 over 2, 1, and then 1, root 3 over 2, root 2 over 2, 1/2, 0. So using this chart backwards, here's how we would find the sine inverse of root 3 over 2. So if it's helpful, you might write b equals sine inverse of root 3 over 2. And then you can do the sine of both sides and say, well, that means the sine of b is the sine of the sine inverse of root 3 over 2. But sine and sine inverse are inverse functions of each other, so they undo each other. So the sine of this angle, whatever it is root 3 over 2. So I come and look at my chart and find the angle that has a sine of root 3 over 2, and I say, oh, that angle is pi over 3. So remember, the answer to the question, what is the inverse sine of, is an angle. So what is the inverse sine of a half? Pi over 6. What's the inverse sine of 0? It's 0. And the inverse sine of 1, pi over 2. So in quadrant 4, the sign will be negative, but we can still solve these problems by thinking about reference angle. And if the sine is negative root 3 over 2, then we can still use our reference angle in our chart and say, oh, that must be negative pi over 3. And we have to write it as negative pi over 3 because this answer must be between negative pi over 2 and pi over 2. So you can't give the answer 5 pi over 3, even though that's equivalent, because it's not in the range of the inverse function. And then sine inverse of negative 1 is what angle has a sine of negative 1, but it has to be between here and here. So which angle has a sine of negative 1? That's going to be negative pi over 2. So you have to give it that name and not the name 3 pi over 2. Okay, so then we'll use our calculator in class to work together on this, and you have to make sure your calculator's in the correct mode. And do note that the inverse sine function is an odd function, so if somebody asks you to find the inverse sine of a negative angle, you could just bring the negative out in the front and do the inverse sine of the positive angle. So we'll work on those together in class. And then you're going to use the properties of an inverse function to find exact values of composite functions, and I'm going to do that in a separate video.